Okay, welcome back to our second video on looking at primary trig ratios and solving triangles, as well as applications of using primary trig ratios. When it's asking you to solve a triangle, what that means is it wants you to determine every single angle that is missing, as well as every single side. When we're looking at these ones here, right now we have no angle other than the 90 degree. What that means is what we're going to need to do is use the Pythagorean theorem to find out the missing variable. In this case, it's our hypotenuse. So what we normally would call our C. So just a reminder, our Pythagorean theorem is C squared equals A squared plus B squared. The A squared and B squared are basically just any of the sides that are not the hypotenuse. So C is going to equal to the square root of 4.4 squared plus 12.3 squared, which is equal to the square root of 170.65, which gives us 13.1. So we can start filling this in. This side here is 13.1. Now that we have our three sides, what we can start doing is finding out one of the angles that we're missing. So what I'm going to start off by is looking for the angle here, the angle of L in green. I'm going to use sine, so I'm going to use the opposite over the hypotenuse in order to find the angle. So sine L equals opposite over hypotenuse. So our sine L is equal to 12.3 over 13.1. I'm going to use the inverse of sine to find out what 13 divided by 12.3 divided by 13.1 equals, and the angle of L is going to be 70 degrees. So now we know that this is 70. The great thing about triangles is once you have two of the sides, you can find out the third one by applying the notion that all the interior angles of a triangle are going to equal to 180. So in this case, M, the angle M that we're still trying to find, is equal to 180 minus the angle of K minus the angle of L. So it's 180 minus 90 minus 70, which leaves us with an angle of 20. So the angle of M is 20, and we can put that in right here. So that's how you go about solving a triangle. You use the tools available to you. Let's look at another one here. Right now, we have what the hypotenuse is. That one's always going to be the hypotenuse, so we can write that right in. And we have two angles, the 90 degree and the 15 degree. So straight off the bat, we can go and solve for angle A. So angle A is equal to 180 minus 90 minus 15. So that gives us 75 degrees. And just because I should have written this out the first time, angle A is equal 180 minus the angle of B minus the angle of C. That's how I got there. Okay, now what we're missing are some sides. So the first thing we can do is go and find out which one we want to look at and go from there. So I'm going to start off by working with 15 because we know 15 is right off the bat. So I'm going to start labeling some other sides. We have opposite and adjacent. So I'm going to start off by finding the opposite side. So I'm going to do sine C equals opposite over the hypotenuse. And I know that sine C is 15, so sine 15 equals x, because I'm still trying to find that out, over 16. I'm going to rearrange for x. So 16 times by sine 15 gives us 4.14 meters. So that opposite side is now found out. can go put that in, 4.14. Using that same side, I can now go and use cosine to find it out. So cosine C equals adjacent over hypotenuse. So I'm using the same angle. So I do cosine 15 equals, going to use, so we're across from A, so we're going to use little a here, over 16. Going to isolate for A. That's 16 times by cos 15. And that's going to give me 15.45 meters. And that's that side. And now everything is labeled. Oh, I forgot to label the 75 here. And we're done. And that's how you can get and solve a triangle. Now, can't always be that easy. There has to be problem-solving questions. And here we are. Here's our first problem-solving question. So it's asking us to calculate the length of AB. Now, the length of AB is this guy right here. We have two separate angles, and we have the adjacent to that angle. So this is adjacent. You can always start labeling this off. Now, if we're looking at this, what we're going to notice is AB here is not really part of its own triangle. At least not a right angle triangle. This is a triangle, but it's not a right angle triangle. That is an acute triangle. Not something we can deal with just yet. We will eventually, but not yet. Right now, what we do have is we can have an angle here, which can give us this side right here, this BD, and we have an overarching angle, so these two 20s together, which can give us the entirety of A and D. So that's how we're going to start off by doing this one. You're going to notice that these sides are all opposites, and we have the adjacent. So if we have opposite and adjacent, that means we're going to be using tan. So our first step is going to be find BD, which is in that lovely brownish orange color that I've highlighted. We find that length first, and then we're going to find the length of AD. And once we find AD, we can subtract AD from BD to give us what AB is. So let's start with that. So we get tan theta equals opposite over adjacent. We fill in what we know. Tan 20 equals x over 100. We're going to rearrange, so we have 100 times tan 20 gives us x, and that is going to end up giving us 36.4. So I now know that BD is 36.4. The next one we want to find is that pink part, pinkish purple. We want to find that AD. And I'm going to underline that in the purple color so we can know which one we're looking for now. And this time, we're still going to use tan because it's still adjacent and opposite. But instead of having our angle be 20, we need to find out what the total angle is between this 20 and 20. So we want this entirety here, which is 20 plus 20, which gives us an angle of 40. So we're going to now input our information in. So we get tan 40 equals x over 100. We rearrange to isolate for x, so we get 100 times by tan 40. And that's going to give us an x of 83.9. Our last step here is we want to find that blue. And how we do that is we're going to subtract AD from BD. So we're going to find AB now. So AB equals AD minus BD. Oops, not BC, BD. So we get 83.9 minus 36.4, which gives us 47.5 meters. And that's the length of AB. Now we're going to get a little bit harder. Now we're going to have a couple of different angles that we need to identify what they mean. When an object is sighted above the observer's horizontal plane, the angle between the observer's sight line and the horizontal is called the angle of elevation. So in this case here, we have the sight line. This is the observer, sight line. So that's an elevation. Just think of it's going up. If it's looking up and this is a horizontal plane, and you're going up, elevation. Now we have another thing called an angle of depression. So here's your sight line, and then you're looking down, hence angle of depression. Down, depression, up, elevation. Those are going to be really important things as we're moving forward looking at these particular equations. Let's start off with an example. So we have Nikki is standing by a parking lot on a sunny day. She is 1.8 meters tall, 6 feet, pretty tall, and she's casting a shadow that is 5.4 meters long. Measure the angle of the sun rays make with the ground. So let's draw this a little out. We got Nikki right here. The sun's coming from over here. Nikki's height is 180 meters. But let's see, and this is her shadow right down here. I'm going to show you guys that in purple. Here's her shadow. This shadow's length is 5.4 meters. There is another angle coming towards the sun, coming down like this. So I'm just going to draw it down. And then here's her height right here. Oops, that was not exactly a 90-degree angle. Still not. Hold on one second, guys. See if I can get this. We don't want to snap to the other shapes. Let's see here. There we go. And that height there is 1.8. What we want to find out is this angle. I'm going to switch colors so you guys can see it right here. We want that angle. This is our question mark. So if we're looking at it from that angle, we can start labeling what we know. The 5.4 here, that's the adjacent. The 1.8 over here, that's the opposite. And then we have adjacent and opposite. That means we're going to look at tan. So we get tan theta equals opposite over hypotenuse. So let's fill in what we know. We have tan theta. Still don't know what theta is. Our opposite is 1.8 and our adjacent is 5.4. And anytime we're finding the angle, we're going to use the inverse. So we have theta is now going to equal to tan inverse 1.8 divided by 5.4. When you put that in your calculator, what you're going to get for theta is 18 degrees. So therefore, the angle is 18 degrees. That was a terrible it. Let me fix that. So that's our first example. Of a problem-solving question that you would get with trig, primary trig ratios. Here's another one. Determine the plane's altimeter reading. So altimeter, what that means, this is a fancy little word, it reads the plane's altitude, how far they are off the ground in reference to sea level. Altitude. What it's saying here is we're going to have an angle of depression. So determine a plane's altimeter reading if the angle of depression to the runway is 40 degrees, when the plane is 12 kilometers diagonally from the runway. Okay, let's draw this out. Let's see what we got here. So we have the horizon. There it is. The plane is pointing down a bit. I was going to put plane because I cannot draw planes. I tried, they looked weird. So I'm just going to write plane. There's a plane here. And it has an angle of depression to the runway. So we got an angle of depression. It's coming down, like so, to the runway. And here's our lovely little runway. The terrible lines. Hopefully that's a better thing. The angle of depression comes from the horizon to this line here. So that is, let me switch colors again so we can see this a bit better. Right here. And that is 40 degrees. The diagonal reading that they're talking about, that diagonal length, is this part right here, from where the plane is to the runway. That diagonal is 12 kilometers. We can also see that there is technically a second triangle, which is how far the plane is off the ground. And that triangle comes right about here, down to the ground. And that part has an angle of 50 degrees. But if that's hitting the ground, there's another line we can look at right here. And that has a right angle, giving us an angle down here by the Z pattern of 40 degrees. Okay, this is a lot of triangle. Let's try redrawing this out. What does this really look like? Well, what it really looks like is a triangle here with 50 degrees, sorry, 9 degrees. There's 50 degrees here and 60 degrees here. Sorry, not 60, 40, my apologies. That's 40. And the hypotenuse is 12 kilometers. What it's asking for is the altimeter reading. The altimeter reading tells us how far the plane's off the ground. So from here's the ground and here's the plane. So what we want is this height right here. Depending on which angle we're choosing, we're going to choose, for argument's sake, this one right here, the 40 degrees. We need to figure out the opposite side. So what particular trig ratio uses opposite and hypotenuse? Well, that's sine. So we have sine theta equals opposite over hypotenuse. So we're just going to fill in what we know. We know there's a sine 40. We have that 40-degree angle. We have no idea what the opposite is, but we do know that the hypotenuse is 12 degrees, so 12 kilometers. So we're going to rearrange. Get 12 times by sine 40 equals x. 12 times sine 40 is going to give us 7.71 equals x. Let's see if it gave us. Didn't tell us how many decimals to keep, so let's keep just one. So we can say, therefore, the plane's altimeter would read 7.7 kilometers, because that's how far off the ground this plane is. 7.7 kilometers in the sky. That's pretty high up. Okay, let's try one more example. One more problem-solving question. Two buildings are 100 meters apart. Building 1 is shorter than building 2. From the edge of the roof of building 1 to the closest to building 2, the angle of elevation, so again, we have a horizon here, and then if we're looking up, that's the angle of elevation, is 25 degrees. From that same point, the angle of depression, so looking down to the bottom of building 2, is 30 degrees. Determine the height of building 2 to the nearest meter. So these two angles give us two different triangles to look at. One triangle gives us the bottom portion of the building. Our other angle, our angle of elevation, gives us the top part of our building. And by those powers combined, they will have the total height of the building. So what that means is we need to find the opposite side of both of these angles. So we have opposite and opposite. So that's what we're trying to find. We're trying to find opposite and opposite. Okay. What's the distance here? What is that distance? Well, that distance is the amount between two buildings. And we have it down here, the 100 meters. So we can just like shimmy on up that lovely distance all the way up here. That's 100 meters. And that is the adjacent side to both of these angles. So what we're going to end up doing is creating two different measurements that we're going to add to the total. We're going to have a lower, let's just do these in colors that I recognize. So we have the lower part of the building, and we have the upper part of the building. So we need to find the lower and upper. And then we're going to have the total at the end, so total. Oops. Just going to erase this one and make it the same color as the highlighter that I used, upper part. From there, we just need to decide which particular trig ratio we're going to use. If we have adjacent and opposite of the SOHCAHTOA, which one we choose? Well, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse. We don't have hypotenuse, those don't work, but tan is opposite over adjacent. So that's what we're going to use. So starting off with the lower part, we're going to have tan theta equals op over adjacent. We're trying to find out op, so that's going to be our variable. It's going to be our x. We know our angle is 30, so we have tan 30. And our adjacent is 100. So we're going to rearrange to isolate for x. So we have x equals 100 times tan 30. And if we plug that into our calculator, we're going to get 57.74. I'm keeping a couple of extra decimal points right now. In the end, we will round it to the nearest meter, but for now, we're just going to keep it with those extra decimal points, just to make sure we don't lose any information. So again, for the upper, we have the same option, so we're going to use tan. So tan is opposite over adjacent. We fill in what we know. In this case, our angle is that angle of elevation, which is 25 degrees. So tan 25. We don't know what the opposite is, but that's what we're trying to find out. And we know that our adjacent is 100. So we're going to rearrange and isolate for x. So 100 times by tan 25. We shove that into a calculator, and what we get is x equaling 46.63. Excellent. So what we're going to now do is add them together. So total is equal to 57.74 plus 46.63. It's going to give us 104.67, and we round up to the 100. Let me just double check my math there. A little bit off, I think. Yes, I am. That should be a 3, not a 6. And run that 3 into 4, that's just going to give us 104. So our therefore statement is therefore building 2 is 104 meters tall. And those are the basics to what these questions are going to look like. They don't get much harder than this. They're all pretty basic. You're just going to need to figure out what you know, what angles you have, and then solve for those missing angles or missing heights.